So most of these questions we're going to be given an acceleration and velocity graph, and then we're going to have to identify which one matches the answer choices. So let's take the first question, for example. She drives east at 30 meters per second. So we have a compass here. North, south, whoops, north, south, east, and west. This is positive. This is negative. This is positive. And this is negative. That's how it works in physics. 30 meters per second, and then she slows to a stop. So her velocity starts off at 30 meters per second. So we can eliminate this, and that works, and this one also works. But then it slows to a stop. So that means her velocity goes to 0. So this does not work. So the answer is B. Bill drives west at 20 meters per second. So that is negative, which is denoted right over here. And in this situation, we're given the velocity graph, and we have to match the acceleration. So this is going to be giving us a positive acceleration. So it's going to be a flat line, but it's going to have a positive acceleration. So this is wrong. This is also wrong. Well, this should be D over here. And this is negative acceleration over here, because it's below the x-axis. It's showing its acceleration of -2, which is not possible because the velocity is increasing from -20 to 0. Only in this situation it works. Why this does not work? Because the slope of a linear function is always going to be constant. And in this case, the acceleration is constant. And over here, the acceleration is constantly changing. Another similar question. We're given acceleration first, and we have to figure out which one matches the velocity. So a cheetah chases the gazelle at 28 meters per second, and a graph is shown. So what shows the cheetah's velocity over time? So it reaches a speed of 28 meters per second. So the end speed is going to be 28 meters per second. This one works. This one does not work. This one does not work. And this one might work. But it shows that there is acceleration. That means the velocity is not constant. That means this cannot work. And the answer is A. Another practice question. So I suggest trying to do this on your own, and then I'll explain this question. Okay. Hopefully you have an answer. Beth drives east at 30 meters per second, but slows to a stop at the red light. So what is that? And a graph of the velocity is shown. So what is the acceleration? So in this case, Beth is decelerating. She's slowing down. So the slope of velocity, a slope of a linear line cannot be another linear line. So we can eliminate these two. And the slope of this line, as we can see, it's negative. So the answer is A. And it cannot be 3 because 3 is positive. If it was like this, then it would be 3. But then she wouldn't be slowing down. So the answer is A for this question. So key terms. So average acceleration. Average acceleration is the rate at which velocity changes over a specified time interval, and it's a vector quantity. So average acceleration is the change in velocity over the change in time. And instantaneous acceleration is the rate at which the velocity changes at a specific instant. So if we're given a graph like this, what is the change in velocity at this point right over here? What is that change? So that is going to require calculus, which we're not going to learn, but it's important to know instantaneous acceleration. It would be more simple if it was a linear line. Then the acceleration is the same, so we can find the instantaneous acceleration at this point or this point, because all the acceleration would be same. So common mistakes and misconception is that people forget that an object can accelerate by changing directions. Since it's a vector quantity, what this entire block of text is saying that it can go either direction because it's a vector quantity. And if the speed of an object remains the same, but it changes direction, that means it's accelerating. And people sometimes forget or don't understand that velocity and acceleration can be in different direction. You can be moving in a different direction, but your acceleration can be in the other direction. For example, when you're slowing down, when you're driving, but then when you're slowing down, your acceleration is backward, but your velocity is still that way, even though it's slowing down.